Hi, today we're going to be talking about KSP and the reaction quotient Q. So you need to know the reaction quotient in order to decide whether a precipitate will form, and you also need it to figure out the concentrations of ions that are required to begin the precipitation of an insoluble salt. And I will explain some information about insoluble salts soon. So some general information about the reaction quotient is that if the reaction quotient is less than KSP, then it forms an unsaturated solution because the system is not at equilibrium. If they are equal to each other, then it will be a saturated solution because they're at equilibrium. And if the reaction quotient is greater than KSP, then the system is also not at equilibrium, so it will form a supersaturated solution. So precipitates form when the solution is supersaturated, which will be necessary for the example problem we will do later. So some information about insoluble salts is that metal-bearing ores often contain the metal in the form of an insoluble salt, and to complicate matters, the ores often contain several such metal salts. We have to dissolve the metal salts to obtain the metal ion and concentrate in some manner the precipitate selectively only one type of metal ion as an insoluble salt.
A solution is prepared by adding 750 milliliters of 4.0 times 10 to the negative 3 molarity of CnO3 to 300 milliliters of 2 times 10 to the negative 2 molarity of KiO3. Will the CeIO3, which is this, with a KSP of 1.9 times 10 to the negative 10, precipitate from the solution? So this is the balanced equation, and you're going to start out by naming this x and this 3x because of the coefficient. So then you have to find a QSP equation. So you're going to do QSP equals x times 3x to the third because it has a coefficient of 3. So that'll be 27x to the fourth. You don't actually need this part, but it helps to think of it this way and then just plug in the numbers later. So you're going to take the 750 milliliters that the problem gives you times 0.004 moles per liters, and then divide that by 1,050 milliliters, which is 750 plus 300, which is the total volume. So then take that, and the liters here and the liters here cancel out, and then the milli here and the milli here cancel out. So you end up with 2.8 times 10 to the negative 3 moles per liter. Do the same thing over here. Take 300 milliliters times 0.02 divided by the total volume, and then you'll get 5.7 times 10 to the negative third moles per liter. So then you're going to take those two values and plug it into this QSP equation. So take QSP equals Ce3 plus, or the concentration of Ce3 plus, and then times IO3 negative to the third because again of the coefficient, and then just plug in the numbers. And then you just multiply it out. So the QSP is going to equal 5.2 times 10 to the negative 10. So you're not done yet. That's the QSP. And then if you remember, the KSP was 1.9 times 10 to the negative 10, which is less than this QSP. So therefore, when QSP is greater than KSP, it's going to be saturated. So the answer is yes.